Okay, we're in section 3.4, and we're looking at partial fractions. And in this section, as you can see what our objectives are: integrate a rational function, recognize simple linear factors, recognize repeated linear factors, and then recognize quadratic factors. So those are the kind of problems that we're going to solve. So we actually want to, and oh, that's the wrong pen. My goodness, just discombobulated. It's because I've been grading all morning. Where's my pen? Okay, here's my pen. Okay, so we're going to be integrating things that look like the integral of r of x dx. And r of x is a rational function. So that means it looks like the integral of a function p over a function q dx. All right. Now, some of these we can actually write as, we can actually do simple long division in order to figure it out. So we want to be able to write this as the integral of some p of x plus a fractional part, let's say f1 of x, and maybe another fractional part, f2 of x or whatever, until we get to some fn of x, and we want to integrate that whole thing dx. Now that looks crazy, but it's actually, this is actually fun. I've always liked partial fractions. Okay, so let's do the first problem, because the first couple problems are we're going to do using simple division. Okay, so if I have the integral over x cubed minus 1 divided by x cubed plus x dx. Okay, so as we can see, let's think. No sines, cosines, no tangent, no trig functions. Doesn't look like an inverse trig, so we can't use that. No exponentials, no logs. So basically, we can't use any of the stuff. No integration by parts. There's nothing that we've learned before that we can try to do this. So the first thing we want to do is literally, since they're of the same power, so the numerator and the denominator are of the same power. Are of the same power. I can simply do long division on this one. Okay, so what in the world does long division look like? Well, I have x cubed plus x, and I am going to divide that into x cubed plus 0x squared. Well, wait a minute. Am I going to do this? I'm trying to think, am I going to get the right answer? X goes in here 1 time squared plus x. And I don't want to do this by long division. This is one that I'm actually going to do by, why am I going to do this one? Oh, I think I know what I did. Okay, we're not going to do this by long division. This one is a partial fraction one. I think I just gave you the answer because I wanted to show you how to do it. So x cubed minus 1 divided by x cubed plus x. Well, that actually equals 1 minus 1 over x plus x minus 1. I did use partial fractions to get this answer, over x squared plus 1. So if you were to multiply that out, that's what you would get. I will show you this. We're going to use partial fractions to get this. Okay. So therefore, to integrate this, to integrate x cubed minus 1 over x cubed plus x dx, that's the same as integrating what it equals, which is 1 minus 1 over x minus x minus 1 divided by x squared plus 1 dx. So now this last term, I need to break it up. So I get the integral of 1 minus 1 over x. I'm going to get minus x over x squared plus 1. And then I'm going to get 1 over x squared plus 1 dx. So now this is very easy to integrate, okay? The first one is just x. The second one is the log of the absolute value of x. Now, what about this one? This one I could do by u substitution, where u is equal to x squared plus 1. And this one's going to give me 1/2 the natural log of the absolute value of x squared plus 1. And then this last one I should recognize as tan inverse. So therefore, this just gives me plus the tan inverse of x plus a constant. Okay. Okay, so yes. So number 2, I'm going to actually do by long division. Okay, because number 2, the power of the numerator is bigger than the power of the denominator. So in number 2, I have x cubed plus x squared plus x minus 1. And that is over x squared plus 2x plus 2 dx. So now for this one, I'm going to do long division. And long division helps, but it doesn't get me where I need to go. Okay, so I kind of really need to do more. So if I take x squared plus 2x plus 2, and I divide it into x cubed plus x squared plus x minus 1. Now we've all done this in college algebra. I take x squared, so we start with the first number all the time. So I take x squared and I go into x cubed and I just get x. When I multiply it back out, I get x cubed plus 2x squared plus 2x. And so now I subtract. And so this gives me negative x squared minus x minus 1. So now I'm going to take x squared into negative x, and that just gives me negative x squared. That gives me negative 1. And I multiply it back out. I get minus x squared. I'm going to get negative 2x. And then I get minus 2. And then I subtract. And that's going to give me x plus 1. So this right here is my remainder. So therefore, I can write this whole thing, this thing, x cubed oh my gosh, let's not do that. We get x, I gotta remember what I had, x cubed plus x squared plus x plus 1 divided by x squared plus 2x plus 2. That is equal to x minus 1. And then my remainder is x plus 1 divided by x squared plus 2x plus 2. So I get that. So the problem is I can integrate this. This piece is integrable. But what do I still do with that hard thing? Okay, I got to figure out that hard thing. Well, actually, that part is not as hard as you think. So if I take the integral of x cubed plus x squared plus x plus 1 and divide by x squared plus 2x plus 2 dx, guess what? I can easily integrate x minus 1. But when I integrate this next piece, if this is u, if u in this here, if u is equal to 2x, I'm sorry, u is equal to x squared plus 2x plus 2, du is simply 2x plus 2 dx, but that's simply 2 times x plus 1 dx, and yay, there's the x plus 1 right there. So its derivative is sitting on top. Divided by x squared plus 2x plus 2 dx. So this is now x squared minus x. And this last piece is 1/2 the natural log of x squared plus 2x plus 2 dx. Okay, so here's the question. How do you find the linear partial fraction? So we want to now find, this is the topic. So we're going to first find the linear partial fractions. And I think you guys might like this because actually it's easy if your algebra is good. And I think everybody on here can handle algebra. All right, so here's the first one. And this is the technique. Okay, so the technique is as follows. So here's a problem. Okay, so I want to compute the integral of 5 over x plus 2 times x minus 1 dx. Okay, so that's what I want to compute. So I'm going to take the integrand. That is 5 divided by x plus 2 times x minus 1 And I'm going to write it as A over X plus 2 plus B over X minus 1. Nice and simple. Okay, so I use the factors of the denominator. So notice we split the rational function using the factors of the denominator. Okay, so that was the first thing we did. So the second thing I want you to do is find the roots of the denominator. So what are the roots of the denominator for this problem? Anybody want to give me the roots? Maxine, what are the roots of the denominator?
Hello?
Yes,
Okay.
I can hear you.
Would it be for like A?
You don't know what A is. You don't,
Oh, okay.
don't know A and you don't know B. Nope, I'm making this real simple. I want to know what makes the denominator 0. What are the roots of the denominator?
1 and then -2.
Perfect. Okay, so now you have identified the roots of the denominator. Okay, so the next step now, which is seems like it would be hard, but it's not, is now we're going to solve for A and B. And how are we going to do that? So we are going to multiply the whole thing through by a common denominator. So let's multiply the entire expression or the equation by the common denominator. And so the common denominator here for us is simply X plus 2 times X minus 1. Okay. So now I have 5 over X plus 2 times X minus 1. And I'm going to multiply it by X plus 2 times X minus 1. And you say, well, that doesn't do anything but divide it out. Absolutely, that's what I wanted to do. And then I have to multiply the whole right-hand side, A over X plus 2 plus B over X minus 1. I'm going to multiply that by X plus 2 times X minus 1. Okay, now anybody that's not with me, please say something in the chat. Let me know. It's important that you are following these steps, and these steps are not difficult at all. So I don't want you to be confused on something that's not confusing. Okay, any questions from anybody? Okay, so this is now an easy step that some students make a mistake with, and that is not distributing. So we need to distribute. Okay, so first off, X plus 2 and X plus 2 and X minus 1 and X minus 1 go. So on the left-hand side, we get 5. On the right-hand side, when I take the expression A times X plus 2, and I multiply it by X plus 2, X minus 1, the X plus 2's divide out, and I get A times X minus 1. And when I multiply b over x minus 1 times x plus 2 times x minus 1, the x minus 1s divide out, and I get b times x plus 2. Any questions? Any questions?
Oh, Dr. Lott, I'm sorry to interrupt. I just had a question about step 2 on finding the roots of the denominator.
Yes,
So basically, it's just setting the denominators equal to 0, yes? To
that's
find the
finding the
roots?
roots. Yes, setting it equal to 0 and finding your roots. Because we're getting
Thank
ready to use those roots, so we need them. Okay. Any other questions? Y'all are so quiet. I never know if y'all are just lost or if you know it, if you're following. Okay. Now that we've done this, now we are going to use our roots. Okay, so we're going to use the roots. So the first one was let x equal -2. So if x equals -2, I'm putting it in this equation. So if x equals -2, I get 5 is equal to a, -2 minus 1 plus b times 0. So I get -5 is equal to -3 times a. So a is 3/5. So we just found a, guys. Let x equal 1. I get, well, how did I get -5 and nobody said anything? Y'all ain't saying nothing. And then I got the wrong answer. This should be 5/3. Y'all ain't saying
Dr. Lott, is it negative 5/3 or just positive 5/3?
it's -5/3. Okay, if x equals 1, I get 5 is equal to a. When I put 1 in there, I get times 0 plus b, and I'm going to get 1 plus 2. So I get 5 is equal to 3b. So b is equal to 5/3. Okay, let's go back to my original problem here. Before we get to the integral, we now are going to write out what this equals. Okay. Okay. Now we know a is -5/3. And we know b is +5/3. So I can write 5 over x plus 2 times x minus 1. Since they're both 5/3, I'm going to factor the 5/3 out. And I'm just going to get 1 over x minus 1 minus 1 over x minus 2. Okay. So now let's integrate it. So now the integral of 5 over x plus 2 times x minus 1 dx is 5/3 the integral of 1 over x minus 1 minus 1 over x. Uh-oh, I think I switched up. This should be a plus 2. X plus 2 dx. Now this is why we learned all those logs, because this is 5/3. I'm going to get the log of the absolute value of x minus 1 minus the log of the absolute value of x plus 2 plus a constant. And what's nice is if we remember the log of a over b is the log of a minus the log of b. So this becomes 5/3. Okay, see you later. The natural log of the absolute value of x minus 1 divided by x plus 2 plus a constant. And I can even go further if I want to make it the natural log of the absolute value of x minus 1 over x plus 2 to the 5/3 plus c. But if you get here, your answer is correct. Okay, any questions? Okay, we're going to jump right in with a harder one. Just jump right in. Let's just handle it. Okay, we have the integral. This is a biggie. 4x squared minus 3x minus 4 divided by x cubed plus x squared minus 2x. This one, I tell you, I just went from 0 to 60. I promise you, but you can handle it. I went from 0 to 60, from an easy one to a what looks completely impossible. Okay, so now remember, all of this depends on the denominator. So the denominator, so notice the power of the denominator is bigger than the power of the numerator, so we can use partial fractions. All right, so what's our denominator? Our denominator is x cubed plus x squared minus 2x. I'm going to factor that. I'm going to factor out an x, and I get x squared plus x minus 2. And I'm going to factor it again, and I get x times x plus 2 times x minus 1. Did I got the same ones again? Oh, doggone it. No, we need a different denominator. I'm not using the same numbers again. Let's see. x cubed minus x squared plus minus 6x. Okay, so now when we factor this thing, we get x squared minus x minus 6. So that factors in the x minus 3 times x plus 2. Okay, that's different. At least it's something different. Okay, so now we have factored it. All right, so now we know our 3 different linear factors. Our 3 different linear factors are going to be x minus 3, and x plus 2. So those are going to be our 3 linear factors. And we also need the roots of the denominator. So what are the roots? X is equal to 0, 3, and negative 2. So we have our roots. Okay, everybody with me on this one. The problem looks horrible. I promise you it does. Okay, but this is an easy one, even though it looks awful. It's an easy one because the denominator is factorable into beautiful linear factors where we have 3 roots. Okay. So, yes.
When it comes to when you're listing the denominator of like x cubed plus x squared is minus 2x, is this supposed to be the same as the ones that?
Oh, this one's supposed to be changed. Yeah, I changed it because that one was that one gave us the same thing as the previous example. I didn't want the same as the previous example. So this should be x cubed minus x squared minus 6x.
Okay, thank you.
Yes. Okay. All righty. So we are going to write 4x squared minus 3x minus 4 divided by x cubed minus x squared minus 6x as a over x plus b over x minus 3. That's our second one. Plus c, now I have 3 of them, over x plus 2. First linear factor, second linear factor, third linear factor. Okay, so we split the denominator into its linear factors, and then we separate the expression as a over x plus b over x minus 3 plus c over x plus 2. Okay, now we're going to multiply by the common denominator. Now we already know the common denominator. Here's the common denominator. This is the common denominator. So this problem, the common denominator is easy. Okay. So now we're going to get 4x squared minus 3x minus 4 divided by x cubed minus x squared minus 6x. That whole thing gets multiplied by the common denominator, which is x times x minus 3 times x plus 2. And we already know they're the same thing. So this is going to cancel with that. That's why we did it. Okay. On the right-hand side, though, I have a over x plus b over x minus 3 plus c over x plus 2. And that has to multiply by the common denominator, x times x minus 3 times x plus 2. Okay, so I want you to multiply that out. Do not, when you get your little x's factors, don't expand them. Just leave them like they are. And I'm going to take attendance. Okay, somebody want to tell me what I get?
I think I got it.
Okay, what do you have?
Oh, 4x squared minus 3x
Mhm.
minus 4
Okay,
equals 8 times x minus 3 and x plus 2. And plus b times x plus 2. And plus c times x minus 3.
okay, so your next step should be just that beautiful. Okay, again, this one is this method is a whole lot less memorizing all kinds of formulas and stuff. You do have to memorize, know what to do in what situation, but it's a lot easier. Okay, so now let's use our roots. Remember, we got to use our roots. Okay, so the first one, let x equal 0. What do you get on the left-hand side of the equation when x is 0?
Would that be -4?
Good. And then on the right-hand side, you want to continue, Maria?
Well, I get 0 plus,
You put in 0 for x. So what happens to the a times x minus 3 times x plus 2?
well, it will be 0 because then you'll be multiplying.
But
Like-
0 only goes in for x.
Yeah, it will be 0 and then a times -3.
So a times -3, good. Keep going, times,
Then it's gonna be 0 again.
well, you 0 plus 2, so that gives you 2. Okay, what
Plus,
happens when you put 0 in the next equation, the next part of the equation?
inside of the parentheses,
It goes everywhere you see x.
yeah, so b times, inside of the parentheses, it will be 2,
Okay,
and then b times 0 is 0.
good. All right, how about the next one?
It's gonna be -3, and then c times 0 is 0.
Good. Okay, so just that fast, by using that, we already know what a is. So I have -4 is equal to -6a. So a is -4 divided by -6. So a is 2/3. Okay. Who wants to take on x equal to, I forget my next root, x equal to 3? Who wants to take on x equals 3? Somebody that has not given me an answer. I want some brave person that generally doesn't talk. Dazair, where are you? Dazair?
I'm right here.
Okay, good. All right, so I want you to put 3 in the left-hand side of the equation. What do you get?
Mm.
Stay still. So you put in 3 here. What do you get? You get 4 times,
3 squared.
yep, which is what?
36.
Okay, so 4 times 9, good. That's going to be 36. Okay, minus. So I'll just write the 36 since you figured that out already. And then you have minus 3 times 3. So I'm going to subtract off.
Minus 9.
And then I still have,
Minus 4.
okay, so now what do I get on the right-hand side when I put in x is equal to 3?
$23.
23?
Wait, hold on.
Oh, you talking about the left-hand side.
Oh, yes.
Okay, the left-hand side, I agree with you. That's going to be 23. But what do you get on the right-hand side?
Three minus 3.
Dizer.
Yes.
I can't see you, so I don't know what you're doing. Okay, thank you. I need you to put a 3 in everywhere you see X over here.
Yeah, I was doing that now.
Oh, okay. So what did you get for the first term?
Would it be 5? A5.
Say it again.
Would it be 5?
Where'd you get 5?
3 minus 3.
What's
That's
3 minus 3?
A parentheses 3 minus 3.
Yeah, and what is 3 minus 3?
0.
Good, that's gone. Okay, let's move on to the next term. Knock it out, just throw it away. Okay, so now what happens at the next term? We get B.
Oh,
X is 3. So I need a 3 to go in here and a 3 to go in there.
would it be 15?
15. And then I need a 3 to go in here and a 3 to go in there.
And would that just be 3?
That would be 3. And then how about the second piece?
0.
Good. So I get C times 0. So that's gone too. Okay, so do you see the process? That's there.
Yes.
You do. Okay, so help me finish this up.
Would it be would it be 15 divided by 23?
Almost. It's the other way around.
Oh, 23 divided by 15.
Yes. Very good. So now B is 23 over 15. Now, how do you think I'm going to solve for C? What do I
Let
need to
X
do?
equal 2.
I let X equal 2. I have one more root. Okay, on the left-hand side, when X is equal to 2, what do I get? Who was just talking?
Jadeja.
Okay, Jadeja, thank you. When you put in X equals 2 on the left, what do you get?
16 minus 6 minus 4.
16 minus 6 minus 4, okay. 16 minus 6 minus 4. All right, keep going. And on the right-hand side, you put in x equals 2. X, oh,
Okay.
x is negative 2, darling. We're wrong. X is
Oh,
negative 2.
-2. Okay.
Okay,
So just
so we still get 16, but we just get plus 6.
yeah.
Okay, so now let's put in negative 2 on the right-hand side.
So A times 0
Good, wonderful. A times 0
plus B times 0
plus B times 0.
plus C. Can you go back up, please? Times 2.
Okay, C time, it's actually negative 2. So C times negative 2. And then you have to put negative 2 in for here. So what is that?
-5.
Excellent. Okay, we are out of time, but guess what? I want you guys to finish this and solve for C. And we'll pick up here tomorrow. Any questions? Picking up here tomorrow.